Hi, my name's John Price. I'm the president of picoSpin, and I want to tell you about our new picoSpin 45 NMR spectrometer. This video is hosted by Cole Parmer, and Cole Parmer is our exclusive worldwide distributor of the picoSpin spectrometer. Here's a picoSpin spectrum of ethyl acetate. So why is NMR important in organic chemistry? Why do we care about it so much? NMR is a spectroscopy that has chemical specificity. NMR can separate chemical groups. It can tell you how many of each kind of proton are present in a chemical structure. So in this spectrum of ethyl acetate, there is a triplet that comes from the CH3 at the right side of the molecule. There's also a quadruplet that comes from the CH2 at the middle of the molecule, and there's a singlet that comes from the CH3 that's at the left side of the molecule. And you see that they're well dispersed. That's because these are different groups of protons. They're chemically distinct, and they appear at different places in the spectrum. NMR is also powerful, though, because it's a quantitative spectroscopy. If we integrate these peaks, it tells us the ratios of the concentrations of the different types of protons. So if I have a mixture of different molecules, I can directly and without calibration measure concentration ratios. Finally, NMR is powerful because it reveals chemical structure. In this molecule, the triplet, which comes from the CH3 at the right side of the molecule, is interacting with the CH2 at the middle of the molecule. And because of this, the multiplet splittings that are observed are the same for the triplet and the quadruplet. One can tell that these two groups are adjacent in the molecule, and so the NMR traces the structure of the molecule. But NMR is expensive. And if you go into any kind of laboratory that does chemistry in any big research center, you will find NMR spectrometers that look like the ones shown here on the left side of the screen. These are large superconducting spectrometers. They use liquid helium. They cost between $300,000 and $2 million. They require a PhD to operate them. They require specialized facilities. There are even larger NMR spectrometers, which are used mostly to study biological macromolecules. And these things can require specialized buildings. They can cost $10 million or even more. The goal of picoSpin has been to build the smallest useful NMR spectrometer. We've drastically reduced the size of NMR spectrometers, and we've reduced the cost. The U.S. manufacturer's selling price for the picoSpin NMR is $25,000, so it's much cheaper and much smaller. Here, the picoSpin spectrometer is shown to scale relative to typical laboratory spectrometer. So what are the features of the picoSpin 45? This box I'm showing here is a complete 45 megahertz pulsed NMR spectrometer. It's for proton NMR of liquids. It can also do NMR of fluorine-containing compounds. The typical resolution is 50 parts per billion. As shown in the previous spectrum, that's sufficient to resolve chemical shifts and also multiplet splittings. It's important to understand about the sensitivity of an NMR spectrometer. For this instrument, if you fill it with pure water and you make a single pulse, you'll get a peak in the spectrum, which will just be one line, and the height of this peak will be 600 if I normalize to the RMS of the baseline. So that's a measure of the sensitivity, and because NMR is a perfectly linear and quantitative spectroscopy, you can scale from the case of pure water to find the signal-to-noise ratio for any line in any spectrum. If the signal-to-noise ratio needs to be increased, you can average together many single shots and get a square root n improvement. This is a small thing. It's about the size of a shoebox. It weighs about 10 pounds. It can go anywhere in a laboratory where a person would be comfortable. It doesn't have any special environmental requirements. Samples are injected into the front panel. There's an inlet fitting and there's an outlet fitting. The total volume inside the unit is about 200 microliters. It's a capillary with 300 micron inside diameter. And you come up to the machine with a syringe and insert the sample, and then you cap it, and then it's filled with the sample, and you can make a spectrum. The instrument does not require you to install any software on your computers. It's controlled by a web browser. There's an Ethernet connection on the back panel. You connect that to your network, and then any computer on your network that has a web browser can be used to control the instrument. You may want to use other software after you've downloaded data from the instrument and you need to analyze it, and there are NMR data analysis packages available for that purpose. With this instrument, we provide a 1-year free license to MNOVA NMR from Mestra Labs Research. So that's a fully featured package. It's the same kind of NMR analysis package that's used to analyze data from large superconducting spectrometers because, in fact, this thing has all of the same features. It's just a very small spectrometer, but the type of data it produces is the same, can be analyzed by the same kind of software. Of course, no cryogens are needed. It has a permanent magnet. In fact, there are no kinds of utilities needed at all. It's like a laptop. You just plug it into the wall and you connect it up to a power supply and you're good to go. Because it's an all solid state piece of electronics, it has no moving parts inside, it's very low maintenance, and it's very reliable. So what is the picoSpin 45 good for? Well, one thing is certainly chemical education. Every chemistry teacher who teaches organic chemistry has to teach NMR spectroscopy because it's the most powerful analytical tool in organic chemistry. And so the picoSpin 45 has a great place in NMR, in organic chemistry teaching laboratories. It can be used to bring NMR directly to the student. It reduces the cost of providing NMR in a teaching laboratory by at least a factor of 5. And so it makes NMR accessible in many smaller institutions where it was not possible to bring it to students before. But there are many other applications. This is a new analytical tool. It's powerful and it's inexpensive. It can be deployed in lots of locations where traditional NMR is just too expensive. For example, in chemical manufacturing, it can be used to monitor reactions. So here is a spectrum before and after reaction of a trans-esterification reaction. You can use a white paper where it explains what all of the different peaks are in this spectrum. You can track the progress of a reaction to check that it's completed, watch how long it takes, and look at the products. In this kind of NMR, which is at relatively low field, we can get a lot of help from NMR simulations. So here's a spectrum of propylbutyrate, and at the top we show the picoSpin spectrum, and at the bottom is a simulation. And you see that they're almost exactly identical. In the old days, when low-field NMR was first introduced, there was a lot of concern about spectral overlap and the difficulty in identifying chemical structure when peaks overlap. But now we have these simulators that are extremely powerful, and they can be used to identify different chemical groups, even in the presence of a considerable amount of peak overlap. There are also quality analysis and quality control applications of the picoSpin spectrometer. For example, let us say that you're manufacturing a mixture of ethanol and ethyl acetate. In fact, this is a spectrum of acetone-free nail polish remover that you can buy at any drugstore. It's 50% ethanol and 50% ethyl acetate. If you look at the right end of the spectrum, there are two triplets that are slightly displaced. These come from CH3 groups at either end of the two molecules, ethanol and ethyl acetate. And you can tell that these two triplets have the same intensity. And that means that this solution has a 1-to-1 mole ratio of ethanol and ethyl acetate. So if you're in charge of quality control of manufacturing this mixture, you can tell very quickly with a purely electronic method with less than a minute of data what the mixture ratio is. Thank you very much for your attention. I appreciate your time. This is coming to you from picoSpin and hosted by Cole Parmer. Thanks very much.